Mr. Kim, you're muted.
Sorry about that. Okay, so what I was saying is I basically graded all the tests that was in person. Those of you who submitted it online, I would like for you to have it in front of you, the test papers, the one that you worked on, so we can just go over the answers together. The class average for just the students who took this on in person was 87.5. Okay, so if you were pretty much like above that, then you did, better. But generally, I had some good scores. I had a couple of bad scores and a couple of, around like B, A minus range. Also, there were a couple of of the mistakes that was commonly made, which I also want to address. And so and I think only 2 students attempted number 4. The one with the carbon 14 isotope question. Okay, so that was just if you had the notes with you, I went over this with you in class, which was the online, and it was one of the homework questions. If you skipped it, that's fine. Obviously, you can skip it. It's I purposely made it so that the middle of the test will be the hardest question. So number 4. And so I've seen a lot of people made just skip that and just went through a lot of these. So let's just go over this, okay, from top to bottom. Okay. If you have the test with you, please just follow along with me. So find the value of the variable by having the same base. After this, I'm also uploading the answer keys online, so you guys can all check it by yourselves if you ever missed this. 2 to the power of 3n minus 9 equals 64. I asked you specifically to have the same base. You don't mess with the left-hand side. You mess with the right-hand side. 64 is 2 to the power of 6. So set them equal to each other, and you should get n is equal to 5 by solving it by pre-algebra y. Okay, that's not going to be a big deal. What was a problem for a lot of us was how to convert these two, 1 over 32 and 16. 16 is still I only gave you base of 2's here, 2 to the power of 4. This is 2 to the power of 5 only if we're taking a look at 32. But if it's 1 over 32, I need to put a negative sign in front of it to make sure that that's going to be taken care of. And so that you put the exponent right next to it, cancel out the 2's, 8n plus 4 equals negative 5. Your final answer should have been 9 over 8. I'm sorry, negative 9 over 8, my fault. So subtract the negative 4. If you put it in a decimal format, it's totally fine. I gave you credit for it nonetheless. So those two are the answers. This one. All right, so find the value of the variables. I have seen some students who do this. Take log on both sides right away. That is not what I was going for. First, your step was to always take the 100 on the other side of the equation so you can get rid of the coefficient, get e to the 5x equals 7.5. That's what you should have gotten. And then take natural log, cancel this out, or just convert it into a logarithmic format. Natural log of 7.5 equals 5x. So you just have to divide that by 5. I get x is equal to, sorry, I just have to type this into the calculator real quick. Or better yet, if I just upload the answer key here. I think I have it right here. Okay, great. So number 3, that should have been 0.40298. How much decimal points? About 100th or 1000th is good, like I always said. So as long as you have around this ballpark, I gave you full credit for it. This one, add the 4. I've seen a lot of students do that. This one was good. Then you take log. If you want to take log 10, log base 6, it's up to you. But I always like to convert into a logarithmic format. So x plus 2 equals log base 6 of 21. And you just put that in the calculator and you subtract 2 from it. X here should have been negative 0.3008, about this much.
Mr. Kim?
Yes.
Can you please quickly scroll up to A and B for a sec?
Yes.
No, A and B.
Oh, A and B. I'm sorry.
Yeah. What does that say for A? I can't read that.
Oh, so A here says 3n minus 9 and 2 to the power of 6. And these two.
No, in the final box.
Oh, I'm sorry. N is equal to 5.
Okay, that's all. Thank you.
Yep. Any question on number 1? Number 2. 1 and 2 were the favorites. I've seen a lot of students who do 1 and 2, and most of the time, you guys get full credit for it. Write the exponential equation for both of the model. I think some of us have kind of not read that correctly. And I said depreciates at a greater rate. You forgot the word depreciates and just saw the word greater rate and saw that it was 1 plus 0.25. I've seen some students who do that. That's a terrible mistake. I said depreciates at a greater rate, which means they're both going to be a minus. It's going to be an exponential decay here. So A is equal to P 1 minus R raised to the power of T for both machine type A and machine type B. This is what I'm going to use for both of the cases. So 2000 times 1 minus 15 raised to the power of T. 2000 times 1 minus 0.25 raised to the power of T. Of course, if you made that as a 0.85, 0.75, I still gave you full credit. It means the same thing. Which value of the snow machine is valued after 5 years? Just plug in 5 and just get the answer. I'm going to skip that portion and say that A, when you plug in T is 5, you get about 887.41. For type B, T equals 5, I get about 830. Can someone help me out here? It was 830 something. 830.50 cents, right? Like that?
I got
57 cents. Okay. So the answer key is also a little bit different for me, but that's what the correct answer was. And so this makes the value of the snow machine A to be valued higher. How long would it take for the snow machine? A lot of students who did part A and B just forgot how to do part C. If you studied the study guide, or if you had the study guide right next to you, I've seen a lot of students to set them equal to each other. So 2000 times 0.85 T is equal to 3,500, 0.75 raised to the power of T. Just verifying, yes. And then you just stop. You don't stop there. You got to solve for T. You divide by 3,500 as you would normally, so you can take care of the coefficients first. But what you also must do is move the value of T on one side of the equation so that T is all pushed towards the right-hand side or the left-hand side of your choice. So I get 2,000 over 3,500 equals this, 0.75 over 0.85, the entire thing raised to T, because that just means the same thing as to do these two separately. That was the key here. So I'm isolating T on one location, then you can take log on both sides of the equation and solve it. Eventually you'll find out that the T here, 4.47 years. That was the correct answer here. Any questions on 2? All right, question 3. Suppose that there was a global cleanup, the oceans movement, that cleared out half of the amount of trash each year. So the other one was a penny doubling for study guide. This is the opposite, it's a decay. So if 100 million, please, I've seen only 100 for solving equations for some students. It's 100 million. So that is the number that you're supposed to use with the decay factor 0.5 raised to the power of T. It's always helpful to write down the equation first before you go on to this. Now, for multiple choice, I am glad that a lot of you guys got the correct answer, which was C and D only. E doesn't work out if you plug in the time. You're decaying at a rate of 100%. Nope, you're decaying at a rate of 50% because only half of it is taken away. A is very conceptual, and I had some students who kind of thought about it, but I'm glad a lot of students who just didn't think that was going to be possible. And you're absolutely right. You keep on taking half each time, which means it's going to be sort of like an asymptote. You're never going to reach exactly 0, or rather you're just going to approach very close to being 0, like question part B is going to ask it, and which is exactly what I did. I asked you to set this equal to the equation and solve for time. So that's all you have to do. Divide this away. You get about 10 to the negative, I think, 18th power is equal to 0.5 raised to the power of T. Solve it using logarithms. I think I can skip that portion. 56.472 years was the correct answer, or just 47 or whatever along that line. Part A, part B, very good. For part C, Some of you guys are still having a hard time understanding what the first 5-year period is. That's from 0 to 5, not 1 through 5. Okay, so if you count from 1 to 5, 2, 3, 4, 5, that's only 4 years after that. So 0 to 5, if you find out the slope, this is going to take a lot of effort, but you just have to plug it in, let the calculator do the work. The slope for that was about negative 19,375,000 tons per year. That's the slope. For the very first 5 years, that's how much you are taking care of the trash each year. Then the next set of years, from 0 to 10, you're doing the slope y2 minus y1, x2 minus x1. I get negative 605,468.75 tons per year. So obviously, it's a significant decrease because if you think about it, it's an exponential decay. For the very first 5 years, look at how, it's like a roller coaster, right? You'll feel the big drop in the first set of years. Then the next 5 years, you're not going to feel that much of a decrease. So to explain it, you're obviously decreasing in rate because it's decay, exponential decay. Any questions? Yes, Kevin?
Can you look at the numbers for the 10 to 5? Like,
yes, oh, you mean like the numbers, what would you get?
Like when you did the formula, like what numbers did you get?
So for 10, I got exactly 97,656.25 for Y. And for 5, it's the same as this one, which is 3,125,000. I think that's when, did I mark it wrong here? It's supposed to be 3.1 million.
And then you divide it by 5.
Divided by 5. Yeah. Okay, and also the slope must be negative because we're talking about exponential decay. Any questions about 3? All right, number 4. So if you guys don't have this written down, you guys can write it down just for the future references. Half-life that it takes is 4,400 years. Carbon isotope 12 means that there's more neutrons in the thing. There's so many isotopes for carbon that it's kind of almost, impossible to list them all. But for the study guide, we did carbon 14. Carbon, that's just the name of it. So you don't have to pay no attention to mine. But what's important is that the time is 4,400. It's a continuous function, and I did the courtesy of bolding that for you. So if you decided to use this, okay, that's just -4 right away. I told you to use continuous function for this. I'm seeing some students who still use this for this one. This is not going to be true. It's a natural phenomenon of carbon dating. So A equals P E R T. I am looking for R. I don't know what A and P is. So for the questions for the study guide, or not study guide, the homework, I asked you to sort of like make up the numbers. The half-life means if I were to start off with 100 of some things, you end up with a 50 left over. That's a half-life. Half of your remaining carbon is left over. So you can do 50 equals 100, e to the power of R, raised to the power of 4,400. Of course, these two numbers have no significance whatsoever, because as soon as you divide that away, you get 1/2 equals e to the power of 4,400 R. You could just use natural log on both sides of the equation and then solve for R, which is supposed to be negative 0.0001575 is what I got. That is the actual rate. So it's going to be about less than 0.01% that the carbon is decaying per year. If your part A is wrong, we can't do part B nor part C. Paleontologist discovers that a remnant of a prehistoric organism, there's about 1% of carbon-12, which means 1% of carbon-12. If I were to use the same equation, 0.1575 times T, because I'm asked to solve for how long ago did the animals exist. I'm looking for time right now. If I divide both sides by P here, the A over P actually represents 0.01 because the whatever's remaining after compared to the original, I have only 1% left over. So that is equal to e to the power of negative 0.0001575 T. Use natural logs all over again. And then divide away the negative 0.0001575. Your final T value here should be about 29,239.1758 years, or you could just assume about, about 29,239 years ago that this animal existed, or this organism started to, exist. How much carbon-12 should be remaining if another specimen, 10,000, so they give me the courtesy of telling me the time. So how much carbon-12 should be remaining? Well, A is equal to PERT all over again. So E, I have negative 0.0001575. Time is 10,000. If I divide away the P, I can just solve for what A over P is going to be. So if I do that into the calculator, you're simply going to type this into the calculator, and what you actually end up getting is 0.2070. What this means is about 20.7% is remaining. Okay, so the original over the aftermath over the original, that tells you the percentage of how much it remains. That is the answer for part C of number 4. As again, not a lot of students have attempted to do this, and which is totally fine. It is a very complicated question. And so I'm just going to move on to the next one here. This one, I had the most questions from every single one of my classes. First of all, I left this blank because I just assumed that you guys were using your study guide and you guys were just going to understand that if you guys decided to copy it, okay, like that, then good for you. So that -3 here gives me 1/8, 1/4, 1/2, 1, 2, 4, 8. So that's what you get. No, I'm sorry. That was supposed to be completely the other way around, so that's my fault. So this is supposed to be 1/8, 1/4, 1/2, 1. That's going to be 2, 4, and 8. Are we all good now for this one?
Yeah.
Yes, there we go. Then I had some students who do this. Okay, so I'm going to use the same x values here and then put it here. And then they are like, Mr. Kim, I don't know what to do now. Well, you put it in the wrong location. You're supposed to put it here. Because remember, like, logarithms and exponentials, everyone had part C correct. They all know how to answer part C. Because part A and part B from that, you guys assume, oh, because the graphs are inverse relationships, right? Inverse relationship we talked about a couple months ago, where it has to be reflected over y equals x. The Fahrenheit Celsius question tells us that you just have to swap up the values. So then you're supposed to be doing this. The x and y values have been completely swapped over. So that was 4 points if you guys just did this, or if you guys decided to use any other values, that's totally fine. As long as I saw that it's in consistency with the graph that you provided me with, which should have looked like this. So the first graph, which is exponential decay, I think you guys could get this right here. And the other one should have looked like that. Okay? And then a lot of students were confused. Is this okay? I get, they're crossed, like I don't get it. Yes, it's totally possible. This is not an asymptote. Which means, like, am I allowed to cross that? Yes, that's a line of reflection. Okay? So if I were to take this as like an origami paper and if I fold it, do I get these two graphs to be matching exactly along those other ways? Yes, it does. As long as that happens, you're good. So that means that from part A and part B, I wanted you to use both conclusions, but if you didn't, that's okay. First of all, y equals x reflection. Along those lines, I needed to see that. And part A, x and f of x values flipped. Those are those magic words, reflection and flipped, that you involve with inverse functions. Okay, so number 5, a lot of students did, but had a lot of questions about. Number 6 was the interesting one. Venezuela has one of the worst inflation rate in history, 1,200% interest rate, which means the rate that you're going to plug in for as a decimal, you're moving the decimal point left twice, which makes it 12. A is equal to P. It's a compound interest rate of weekly. Danny, if it's weekly, how many weeks are in a year? 52. So 1 plus 12 over 52, 52t. This everyone got, I think. Whoever attempted this question. So what would the amount of coffee that was about 24 Venezuelan bolivar? That amounts to the same amount of price, let's say $1 or $2 back in like maybe 2000, early 2010s. But now after a year at this inflation rate, the number should surprise you. 24 Venezuelan bolivar times 1 plus 12 over 52. 52 to the power of 1 time is 1 year afterwards. This A, that 1 cup of coffee after a year, you need to pay about 1,173,260 Venezuelan bolivars. So you need to bring actual suitcases just to buy a cup of coffee. And that's all going to be cash that you have to pay for. After how many months would it take for the same price of coffee of 24 Venezuelan bolivar to reach about 1.0 billion, not million? I've seen some students who just put million and just moved on. It's 3 more zeros after that. That kind of threw some people's off for their answers, and I took some points off for this. But all you got to do is just set them equal to each other, right? So 24, 1 plus 12 over 52, 52t, divide by 24. And some students actually forgot to put 52 up here too. Like I've seen so many errors with this, and they didn't really quite understand, okay, what am I supposed to do with the months? Well, solve for t, which is in years, and then after that, just multiply by 12. Solve for t. Okay, that's always in years, right? So when you do the math here by using logarithms after that, you get t is, I think, 1.62497 years. But that's not what I asked you for, because I asked you to find in months, 19.5 months. Just multiply that by 12. So after about a year and a half or so, that reaches about 1 billion Venezuelan bolivars. All right, last question, number 7. It was really unfortunate that I think only one student got this right for part A. The rest of it was okay. This is no solution. You guys rushed it. Lateral log of x minus 1 over x plus 2 equals 1. A lot of you guys understand the quotient rule. This, in an exponential form, x minus 1, x plus 2 equals e to the power of 1. That's the equivalent exchange between the logarithmic form to an exponential. X minus 1 equals e times x plus 2. E is just a number. Don't get confused by that. X minus 1 equals ex plus 2e. Move all the x's and move all the numbers. So you get x minus ex is equal to 2e plus 1. You can kind of like factor out the x here. Sorry, I'm not writing the decimal values. I know that the answer might be a little bit different. I mean, the process might be a little bit different. But if you type this into the calculator at the end, what you're supposed to get, and what I saw in a lot of students' papers, is that it's negative 3.74593. Plug that in, please, back, check. You get a negative number for natural log. I can't have that. No solution. Okay, so if you show me all the work and you just forgot to write this, I just subtracted 1 point from that, because that all your work is technically correct. This one, you'd use quotient rule is equal to 2. 5x plus 1 over 2x minus 3. Guys, I did not put anything there. That means you can't just make up a number. The default number is always 10. 10 squared. That's the equivalent exponential form, which makes it 100. 5x plus 1 equals 100 times 2x minus 3. You do the math here. You get x is about, in fraction, 301 over 195. That is equivalent to 1.543. That's the answer for part B. This one has no problem here, because if you multiply back into the function, you get a positive number. As long as you have a positive number inside that parentheses, you're all good. Next, I have seen students who do that. 6x minus 8 equals 2x. 4x equals 8. X equals 2. Can someone tell me what's wrong with this? Because I just write 2 here, x here, and I just don't think anything's wrong here, doesn't it? Yes, Abby? X squared. If I gave you 1 as quotient rule, well, this was also quotient rule too. This is power rule, okay? I don't know why I gave you so many quotient rules here, but that's a power rule in which that's going to be x squared. It's a quadratic, so you got to move everything to one side, and what I was looking for is not this type of answer. X squared minus 6x plus 8 equals 0. Going back onto how well you do on factoring. Sorry, that's not true. X minus 4, x minus 2. Solve and check to see that both of them actually works out. You don't always cross out the lower value and say that's an extraneous solution. Sometimes it might not happen, the extraneous solution there. Last one, yes, there was an extraneous solution. Log of x minus 4, 3x minus 10 is equal to log of 1 over x. Cross out the logs. X minus 4, 3x minus 10 equals 1 over x. Cross multiply. Move everything to one side. Factor. And then solve. Okay, x equals 5, x equals to 2. The one thing that is not going to work is that. Because 2 minus 4 is a negative number, and I can't have that. So that means that that's going to be an extraneous solution. The only solution that should work is just x equals 5. I'm glad that a lot of students were able to do that. Okay. So that was everything is worth 12 points. I deducted the points based upon how the magnitude of the answers that you showed me really determined how much partial credit I could give you. If you showed me, demonstrating me some level of understanding, but you kind of forgot that there was a 52 in here, or, you know, these silly mistakes, I didn't try to take too much points off for it. But if you didn't show me any level of understanding, then if it was worth 5 points, I subtracted -4 or -5, depending on what you showed me, demonstrated for me in terms of your answers here. Okay. So I'll upload the answer key for you guys to see, but that is the all the questions here. And also extra credits is applied. It's already on the Genesis, so your marking period 4 grades should show up as not like NG, it should show up some grades, except for those of you who took it online. Okay, if you guys have any questions about the test, please let me know. That was test number 5 with exponential and logarithmic. And now we can move on to trig. I think we got out here at, when did we get out here? 52. Okay, so we have about good 25 minutes left. All right, so today we are starting a long series on trigonometric functions, okay? Yes, I know it's a Friday, and I'm not going to try to give you a homework today. To some assignment that's uploaded on Schoology, please ignore that. I'm going to change it so that it's not going to be a homework. You guys had a test this week, and I'm going to just have you guys a clean weekend off. And I want to start fresh next week with the homework and things like that, okay? Just raise your hand if you have seen radians before last year in geometry.
Oh, like I remember, like it was a setting on the calculator.
That's the only way of you being exposed to radians?
Yeah.
Really? You guys didn't do radians last year at all in geometry? Okay. All right. So that means, okay, so that's a good place to start. So I think, if you guys had advanced geometry last year, it should have been part of your curriculum. It's just that, who's this? Okay. It should have been part of your curriculum. Because of COVID and everything, that's why we ran out of time and we weren't really able to do this. This part, okay, it's gonna take some time, okay? It's gonna get some time to get used to. You're not familiar with radians. I wasn't familiar with radians when I was first exposed to this, and you really confuse the life out of me, okay? You're not dealing with regular numbers, and you will see this type of graph now, okay? And you guys have to sketch that. All right, and it's not going to be that bad as compared to other. Well, it's going to be bad, but it's not. If you know the rules as to how to sketch these and understand it, of course, I'm going to give you as many practice questions as I can. And if you guys study on your own for this, and memorize the formulas, you should be all okay. The very first thing we need to do though is, because you don't have a building blocks for something called radians, we need to do that first. Okay, so first of all, I need you to write this down. The unit circle is simply circle with a radius of 1. Okay, that's really a no-brainer, but it's very important for this, that you guys know what, whenever I say a unit circle, that just means a circle with a radius of 1. Okay.
Can you draw that?
Yes, of course, yes. This is a build from SOHCAHTOA that I know that you guys remember from last year, yes? There's one thing from geometry you remember is SOHCAHTOA, in which now that extends when you come back 2020 September for Algebra 3 next year, or pre-calculus. what I'm teaching you right now will just go right into that. I think I heard from Ms. Wallace, that's what you guys start off with, trig graphs, if I'm not mistaken. Okay. So a unit circle is a circle with a radius of 1. But I can't really talk to you guys about the unit circles if you guys have no idea what radians are. So I'm going to help you to understand what radians are. And it's one of those things where I always kept on telling you, hey, check your radians and check your mode to change from radians to degrees. And you're absolutely right. Radians, if you guys want to just get a general idea of what it is, you remember how we did exponential to logarithmic format? Like you guys were translating like Spanish to English, you know, something like that. Radians to degrees, you're just translating it between the two. So between, like, you know, whenever we were exposed to degrees, like back in elementary school, hey guys, this is 90 degrees, this is 180. If you rotate around the circle, that's 360. We understand what degrees are at this point, of course, but in high school, we translate that into a different language called radians for the purpose of doing trigonometric functions and graphing. Okay, so that's all there is to it. And if you guys want a general definition of what radians is, and I'm going to show you a little animations too as to what that is. This is a definition of what a radian is, okay? It is a standard unit of measurement of an angle when the arc is equal to its radius. Okay, so what the heck does that mean? I'm going to show you in just a bit first, but I need you to just have the technical definition written down. Okay, and let me just show you a quick animation here. And before I could do that, I'm going to stop sharing the screen and then just share my the internet page here. You guys can do this too, but I mean, you don't have to do this on the computer. I mean, if you guys just go to definition of radians in Google, okay, the very first thing that you will see in this math is fun illustration, like this is a really good demonstration of what a radians is. So if I just zoom in here. So again, you take this radius and you imagine if I were to place it right along the side of one of this part of the circumference of a circle. So that measurement here is called 1 radian. In equivalent degrees, okay, so if you were to convert it, it's about 57.2958 degrees. Where did this number come from? I'm going to also explain this to you as well. But that is what a radian definition is. Okay, of course, I always like to tell you the content behind it, but some of us are just interested in, okay, I get it. What do you exactly want me to do? The formulas and technical how to do these types of questions is on the next slide. So I'm going to stop sharing the screen. Do we all kind of get the animations though? If it's one radius, and if I just put it on the side of the circumference, how much angle that is equivalent to 1 radian. Okay, going back to sharing the screen with my iPad here.
What's the number 57?
57.2958. So 1 radian is equal to 57.2958 degrees. This is an old classic way of writing a radians. No one really does this anymore, but that's 1 to the power of r, but that's called radians there. Again, this is not a definition. So if that radius was just kind of placed on top of the circumference there, that one New York slice piece of pizza slice, that is the radians. Okay, that angle of measurement is called the radians there. Okay. For the purpose of understanding how to calculate it, I want you to guys take a look at this question. Okay, this will help you understand where the formula is coming from. I'm going to show you, and then we're going to end the session by showing you the formula there. We all know what a 360 is, yes? It's a full circle, and I'm going to give you the radius as 10. Sorry, I'm going to give you the radius is not a unit circle, but let's just go with this here. Do we all know what a formula for a circumference of a circle is? Amelia, what would that be? That's area.
Oh.
2 pi r.
Oh.
Okay, 2 pi r. Guys, the definition of pi is circumference divided by the diameter. When I don't know who discovered this first, but you take any circular objects, okay, and you divide by its diameter of any circular object, and from a basketball to the earth to the, like, you know, anything that's has a circular type of shape, we by taking all that data points, they determine this value by doing that exactly. You measure the circumference and you divide by the diameter. That's what a pi is. So if you multiply by diameter on both sides, you get a circumference basically. So the circumference of this circle here, Jamie, what would that be? 20 pi. Good. So I need you guys to pay close attention to what I'm doing here. The entire pizza crust, okay, of this pie is 20 pi, because that's what a circumference is, right? So imagine the entire pizza crust is 20 pi. Question number 2 is very important here. How many radii, that's the plural for radius, do you need to add to make up the circumference? So what that means is, let's say the radius is 10. I take that and I, you know, and I put it along the side of the circumference, so that is 10 there. Obviously, that is not enough to go through the entire circle, right? So how many, okay, how many of this radii do I need to make a full 20 pi crust of the entire pie? So what I'm asking you to do is, how many of these pieces of 10s do I need to make the entire 20 pi of a circle? What would I do to figure that value out there? We're talking about how many radii I would need, Polina? 10x equals 20 pi, exactly. We want to find out how many of these radii, because x is the number of radii. If I multiply that with 10, because every single one of those radii is 10, if I have 3 radii, that's 30 in terms of length in total, right? But the total I want to get to is 20 pi. So how do I get x by itself here, Polina? Can we just actually leave the pi alone and just get x by itself here? Divide by 10. So what is x going to equal? 2 pi. Okay? And the reason why I put a little star next to it is because you basically converted now the 360 degrees into how many radians that is. If you guys go to your calculator, okay? If you guys go to your calculator, if you guys want to if you guys do sine of 360, which is in degrees mode, versus sine of 2 pi in the radians mode, they give you the exact same thing. Well, they give you 0, but that really doesn't help. But the 2 pi is equivalent to saying 360 degrees. Congratulations, you learned how to translate between degrees into radians for the very first part, okay? That's the definition. How many radii does it make the entire circumference, okay? If you guys want to skip all of this portion in the middle and go straight to the fact that, okay, so Mr. Kim just wants me to memorize that 360 is 2 pi. Okay, I get that. That's another way of memorizing this too. And I really do not care about how you absorb this material, but I need you to understand how to translate between the two. Okay? So 360 is 2 pi. Any questions? Let's do 2 more like this.
2 pi in terms of like radians, right?
2 pi radians, yes. 2 pi radians. So you need 2 pi radii to make a full circumference. So how about we take a semicircle? Can we just do the same 2 problems again? Can you tell me what the length of the arc AB is? In other words, what's the length of the crust? Half of the crust here. We're not taking the, so that's the circumference divided by 2. How many radii do you need to add up the arc length? You guys can see that I'm trying to ask you guys to understand how you convert 180 into radians here. Radius is still 10, by the way. It's still 10. Can someone tell me the answers to number 1 here? What is the length of the arc AB? It's just half of the entire pie of the, I'm talking about the pizza. So the length of the crust of that rainbow shape right there. If you guys are having a hard time understanding this, okay, take a look at the example from the beginning. We found that the entire circumference, and I know everyone in this room is comfortable finding the circumference. This is 20 pi, okay? Same radius. I am just cutting that in half. So if the entire circumference was 20 pi, I'm asking you to find just the half of it. Kevin?
10 pi.
Just 10 pi, okay? Because you know that the entire circle was 20 pi. So the other half, I'm not talking about the length of the diameter, by the way. I'm just talking about the length of the outside, the crust, is 10 pi here. So now the question is, again, how many radii do you need to add to make up the arc length, which is just 10 pi now? Okay. If we go by the formula that Paulina just gave us, we can say that the radius was 10 times x, because we want to find out how many radii I need to get the arc length that we just found, which was 10 pi. So Kevin, what would x be in this particular case?
X equals pi.
Guys, you guys need to understand what that means. It means that you guys need about 3.14 radii. Okay, you need to have 1 radii here. Okay, that's 1 radii here. That's another radii here, and that's another radii here, and just teeny tiny bit, which is about 0.14, to make up the entire arc length of that half circle. Again, the connection is, if you want to skip the conceptual part of it, then just remember this. 180 is pi radians. 360 was double that, so it's 2 times pi radians. I hope you guys can see the pattern here. Okay, so 180 degrees now becomes pi radians based upon that fact. Okay. Last conceptual problem, I promise, and let's go over this through things together so that I can just kind of, I think you guys are getting kind of like, you know, like understanding what this is about. So now I cut this in half once again. Now I'm talking about 1/4 of the circle here. What is the length of AB? I know that I didn't really label it for you, but let's call this A and let's call this B. I'm talking about the length of that. Remember the entire pi with the radius of 10, this entire thing was, the circumference was 20 pi from the previous notes. I am taking this and taking only 1/4 of it, so I need you guys to write this down as 5 pi. The length of only this portion should be 5 pi. So then how many radii do I need to add to make up the arc length? Same thing. I do 10 times x, because the radius is the length of 10. How many of those do I need to get 5 pi? Divide by 10. I get x is equal to pi over 2 radians. Okay, so 90 degrees is equivalent to saying pi over 2 radians there. Okay, since you guys were never exposed to radians in geometry, this is going to be a little bit tough to understand. But once you get the hang of it, because I am never going to ask you how to derive radians from that. All I'm going to ask you to do is to be able to be fluent in converting between the two. So if I give you 90, well, how many radians would that be? Oh, that's pi over 2, Mr. Kim. That's what I need from you. Any questions? Because next slide, I really need you to write this down, because this right here, for those of you who just likes the quick and easy method of doing this, this is really simple to get radians once you understand the rule of 180 here. Can someone tell me how many radians was 180 degrees once again? Yes, Kevin?
1 radian.
No. Because radians, we're talking about in terms of pi. It was 1 times 1 pi radians, okay? That is the magic number that if you memorize that only, you can find out all the other radians based upon the degrees that you have. 180 is pi radians. That's what we say. To go from 180 to 360, we doubled it. So guess what? 360, as we found out before, was 2 pi radians. 90 degrees, you were dividing it by 2. So the number of radians was pi over 2 radians. Okay? Do you see the patterns here? Every radians right there that you get is always going to be in terms of pi. Not always, but most of the time, it's always going to be in terms of pi. And for trigonometric functions and the things I'm going to give you, assume that radians will most likely 95% of the time, it's always going to be ending up in pi's. It's got to have pi's in there for radians there. For 60 degrees, if I were to ask you to convert that into radians, someone kind of think about it and just raise your hand if you think you have the answer for this. Jamie? Pi over 3, because that's pi, which gives you 180. That's divided by 3, so I just got to take that and divide it by 3. Abby, the next one, 45? Pi over 4. 30 degrees here. Liz? Pi over 6. That's it. So if you want the fast and quick, easy method of finding what the radians is, that's how I always do it, okay? I don't imagine this radius going on top of a little pizza crust there. That's just too much work. Okay, so you just want me to memorize this, okay? And then everything else just comes as a ratio of the other ones. Okay, that's really easy to remember. Okay, that's what I need you to have down in your notes there. And then I'm off to the last slide of the day. I'm going to give you 2 questions, and I'm going to give you formulas as well, and I need you to write this down, okay? So the formula for radians versus degrees. I need you to remember that every pi radians is 180 degrees. And if you guys want a technical, really nice formulas to do that, here we go. Okay, that's how you can always do it. So we have been just dealing with this where it says, if I were to give you, let's say, oh, I'm sorry, we were dealing with this here. That states, if I'm giving you any type of degrees, I have to just divide it by 180 and put a pi right next to it. That's how you always can determine the number of radians that's going to be. Or vice versa, if I give you the radians and if I ask you to find it in terms of degrees, then you just have to swap these two up. Okay, because these two equations are going to be equivalent to each other. It's just that you just solve for degrees here, just moving it by the reciprocal of 180 over pi. The conversion of degrees into radians is what I need from you, okay? So, and then if you guys are done writing that down, use the formula to figure out what 145 degrees will be in terms of radians. Please leave in terms of pi. Don't multiply by 3.14. That's just going to be a crazy number. I don't want to see that. Convert this into degrees. And then that's going to be it for today. So write the formulas down. Find out the answers to these two. And I am going to just leave on this note and say, you guys do not have any homework for me today. Okay, I uploaded for you guys on Schoology. Don't worry about that. I need you guys to have the formulas written down. I think that's good enough. And on Monday, I'll give you some worksheets based on this. Okay. Where's the what? Yep. Oh, but Danny, if you do that, you're going to get a decimal value. So you don't want to do that. So you just want to do this over 180. Degrees over 180, you just put a pi right next to it. And I know that TI-84 or TI-83 or whatever you guys are using, they always give it to you in terms of decimals. If you guys want to convert it into fractions, go to math, and I think it's the first one that you see. From decimals into fractions is what you guys always want to use. Okay. All right, so 145 degrees here, 2 pi over 3. I think for the first one, degrees into radians. Can I have a volunteer for this? All right, I'm going to call on Nora, do you have it? 29, you said? 29 over 36 pi. I have to do this. And then if I did, well, I have to use the calculator for this one, but 5, 3, 36, 5, 2, 45. Oh, excellent. So 29 over 36 pi, that should be the correct way to do it. Great job. Last one, 2 pi over 3. I want to convert them to degrees. Andrew, do you happen to have it? Okay. Tony, what about you? Not yet? Okay. Can I have a volunteer for this again? Yes, Abby? 120 degrees. The easy way I always remember it is just plug in pi as 180 degrees here, because it's just going to give you the same pi as 180. 2 times 180 is 360 divided by 3, 120 degrees. So this is how you convert between the two. Right now, I'm going to leave it here. Enjoy your weekend, and I'm going to see you guys on Monday. No homework. I'm sorry, 145 degrees? 120 degrees. 120 degrees.
Maybe I'll look it up.